We said the molecular orbitals extend over the entire molecules because all orbitals of all atoms take part in the construction of the molecular orbitals, and that valence bond is a visualized bond that rises from the localized electrons between two adjacent atoms. Now, to create orbitals that are delocalized between adjacent atoms, we need to combine both molecular orbitals and valence bond theories. We can add or subtract in phase or out of phase the atomic orbitals of two adjacent atoms, so the overlap of orbitals creates either sigma bonds when head-to-head atomic orbitals overlap or lateral overlap that results in the formation of the pi bonds. We said before when hybridization happens, the resulted hybridized orbitals can form sigma covalent bonds and the unhybridized orbitals can form pi bonds. We need to expand on the concept of how sigma and pi bonds form. Let's first consider the formation of the 4 sigma bonds of methane. The 4 hybridized sp3 orbitals overlap with 4 hydrogen 1s orbitals. Here you see the representation of the overlap of one of the sp3 orbitals of carbon with 1s orbital of hydrogen. The overlap is head-to-head. But you have 2 possibilities for each of the sp3 orbitals overlapping with the hydrogen 1s orbital in phase addition, and the result is a formation of sigma bond, where both of electrons are in sigma bonding state with lower energy than the uncombined state. In case of the out-of-phase addition, anti-bonding sigma star molecular orbital forms that only filled with 1 electron in excited state. Notice in our example here, we used the hybridized sp3 orbital. The same thing happens with the sp2 and sp hybridized orbitals. Moving to the combination of unhybridized orbitals. When 2 unhybridized p orbitals overlap, usually they are in parallel positions to each other. The addition of the wave functions gives the pi bonding molecular orbital, and subtracting the wave functions give pi antibonding molecular orbital. By now you know each time we have triple bond, this means we have sp hybridization. Let's look at the acetylene molecule. We have 2 carbon atoms. Each carbon is bonded to 1 hydrogen atom from a side and the other carbon from the other side. The 2 carbons in the acetylene molecule undergo sp hybridization. Each carbon has 2 hybridized sp orbitals that form 2 sigma covalent bonds. 1 sigma bond with the s orbital of the hydrogen atom from one side, and the other sp orbital forms sigma bond with the other carbon sp orbital from the other side, due to the head-to-head overlap between the sp carbon orbitals. Each carbon has 2 unhybridized 2p orbitals as well, that form 2 pi bonds bilateral overlap with the other carbon unhybridized 2p orbitals. Notice the triple bonds between the 2 carbon atoms. One is sigma bond that forms due to the sp overlap between the 2 carbon atoms, and 2 pi bonds that form due to the 2 unhybridized orbitals lateral overlap.